Good day, guys. Welcome to my video. Now I'm going to do corrections based on the test that we wrote on Sunday. Okay. Now please try to pause the video, shoot a picture, because the questions will not be on the screen anymore. Okay. Now this is the first question based on vertical projectile. Let me show you the continuation. Now this is the last part of the question. Okay. Take a peek. Okay, now let me try to increase this one. We'll take a peek of this one and take a peek of this one too. Okay, now I'm going to change swap screens and come to my whiteboard. Okay, now you guys have questions on your phone, so you are going to follow the entire session without actually seeing the questions because you have them already. All right. Okay, now the first question says, it's question 3.1 based on vertical projectile. Explain what is meant by the term projectile. Okay, so that will be question 3.1. Okay, I think this is too thick. No, but it's fine. So when we talk about a projectile, we are talking about a motion of an object under the influence of gravity. Okay, now that is the term projectile. It is a motion. It is important to state that we are talking about the motion, a motion of an object under the influence of gravity. So those two terms have to be there. Okay, now 3.2. Okay, now I promised that I won't come back to the question because you guys already have the question. Okay, yes. Now 3.2, it says, show by means of suitable calculations that the maximum height of this rocket reaches above the ground is. So basically you need to show that the maximum height is at this point. Okay, you need to prove using calculations. Now let me try to go through the scenario with you. It says a 7,200 kg rocket blasts off vertically from rest. So initial velocity is 0 there. Okay, now from the launch pad of a constant upwards acceleration of this. Now acceleration is given of the rocket. Okay, when it reaches a height of 555 meters, the engine suddenly fail. So meaning the engine is off. Now it becomes projectile. It was not a projectile. Now it becomes a projectile at this point where it's written motor switches off. Okay, so I wanted to explain the scenario, hence I came back. Now you are required to prove that this is the maximum height. How are you going to do that? Now you have to break this into two. The first part, it was not under free fall. It has its own acceleration given there as 2,2 meters per square second. Now from this point up to the maximum height, it is under free fall. Therefore its acceleration is 9,8 meters per second. Okay, Now those are the few things that you need to note. Now let's go to the whiteboard. Okay. How do I clear this? Not you. Okay, I had a way of clearing something. Okay, by the way, let me just not ruler, sorry, but erase. Okay, it's fine, guys. Now we are doing question 3.2. Okay, now we are required to prove that the maximum height is of the value 679,529 meters. So what do we do there? Okay, first things first, I always teach you guys that you have to show me the direction. It's either you write it in words. In my case, I took upwards as positive. You can write it in words that upwards positive. Okay, you need to show that one so that the marker knows what you're talking about. Okay, now also you need to do data, not a must, but it is advisable from me. Okay, now when you do data, what is given? Now under the gravitational force, not gravitational force, I'm sorry, under the acceleration of 2,2 meters per square second, which is a given acceleration, and it's upwards, so it's positive. Okay, it's meters per square second. We were told that the rocket launches from rest, so its v initial equals to 0 meters per second. Okay, now the height traveled before the engine fails, which is why it is given as what, 555 meters. Okay, now vf, it is unknown. When the engine turns off, we don't know what was the velocity. Okay, and that is what we need to determine in this case. Okay, we don't know this too, and also don't know time. Okay, now this is what I tell my students. You have 4 equations of motion. Okay, you have a vf, which is equals to vi plus a t. Okay, you also have a vf squared, which is equals to vi squared plus 2a delta y. Okay, then we also have delta y, which is equals to vit plus 1 over 2 at squared. I'm sorry, this is a t squared. You also have delta y, which is equals to vf plus vi over 2, all multiplied by time. Okay, now this is the 4 equations of motions that you are going to have. Rule number 1, choose the equation that has only one unknown. In this case, we have 2 unknowns, so the equation that we are going to choose must not contain both vf and time. And in this one, we cannot choose it. This one, we cannot choose it. Okay, now we are left between this and this. This has only vf, this has only time. Now what are we looking for? We are looking for vf. Okay, so meaning that the equation that has time we need to avoid. then you cross this one. Now this is the equation you're going to use. That's how you need to select your equations. Okay, now I'm going to rub the useless ones in this case and continue with my calculation. Okay, now since you have got the equation, what do you do next? You substitute. When you are writing, just to copy the correct formula from the formula sheet, writing it down is a mark. Then you also need a correct substitution. Okay, we are looking for VF. Vi it is given, so VF squared is equals to Vi, which is 0. You need to show it. We know that 0 squared is 0. You need to show it because you are going to be marked for correct substitution. Now acceleration in this case is a positive 2,2 because it's going upwards. Okay, now what is the height? The height when the engine stops. Okay, okay, I'm sorry about that. I had some network glitches. Okay, now the height when the engine stops, it's this delta y, which is equals to 555. Okay, now when you press your calculator, you are going to find that VF squared is equals to 2442. Now VF, because we're not looking for VF squared, is equals to 49,42 meters per second. Now when you take a square root of a number, you're going to get a plus or minus. But since VF is going upwards to the direction that we assumed, you take the positive one and you need to show that it's upwards. Okay, both magnitude and direction. Why? Because velocity is a vector quantity. Now the question wanted to prove the maximum height, so what we have only achieved is to get the velocity here. We have the velocity at this point. If you can see my cursor there, we have the velocity at that point. Now we have to use this velocity because we already know that velocity at maximum height is 0 meters per second to get the height from here to there. Now we're going to add that height with the existing height here so that we can get the overall height. Alright, we are halfway through. Okay, now okay, let me okay, it's fine. Now let's take note of the value. Okay, and the data will now change. Okay, I need to stress on this part now. The data will now change. Okay, now the velocity that we've gotten previously, it's a 49,42 meters per second. Now we are continuing from this one. Now under data, this velocity now becomes an initial velocity. Okay, 42 meters per second. Now final velocity, because we're going to deal with the maximum height, it's a 0 meters per second. Now acceleration in this case is minus 9,8 meters per second squared. delta y, it is unknown, we are looking for it. Time, it's also unknown. Now with the given equations that I gave you before, you cannot choose an equation that contains both y and t. Okay, now the equation that I'm going to use, because I'm not interested in time, is the one that doesn't have time, which is a vf squared, okay, sorry, vf squared, this is an equal sign, which is equals to vi squared plus 2ay. So definitely I'm avoiding any equation that has time. Now final velocity is 0 squared, which is equals to initial velocity 49,42 squared plus 2 into minus 9,8 y. We are looking for that y. Okay, now that squared becomes minus 2442. We had this value previously, so I just copied from the previous question. This is minus 19, minus 19.6 y. Now if you divide, you will get that y is equals to, and remember this thing is traveling upwards, so the value of y will now be positive. It will be equals to 124,59. Okay, now maximum height h will be equals to this value 124,59 plus 555. Now this value will give you 6. I mean, if you add 1 and 1, it will give you 6. 2 and 5, it will give you 7. 4 and the last 5 will give you 9. Then after comma, you have 959. I mean, this is height, so it's in meters. Okay, now this value, it is consistent. 679,59, it is consistent with 679,592 meters. So you have now proved. So that is the final answer for that. Okay, now the next question says hence determine the time taken after the engine failure for the rocket to come crashing down the ground. So basically this question says calculate the time taken from this point up until it crashes here, it hits the ground. Alright, now I'm going to clear because we have lack of space. You guys keep note of the values you have. Okay, that value, we have it already on the question paper. We're just proving that that is the maximum height. Okay, all right, now I'm doing question 3.3.1. okay, let me also remove this one. I'm doing question 3.3.1. Now question 3.3.1, VF is equals to VI plus A delta T. Okay, now there are many ways of doing this question. Okay, now, okay, not this one, but I think the next one. Now this question says determine the time taken, okay, after the rocket failure. Okay, now from using this one, I'm going to take this motion here first. I need to explain this one. From here, when we had the initial velocity after the rocket switches off as 49,42 up until it's 0 at maximum height. Okay, now when we substitute, VF will be 0 because it's at maximum height. Then this one will be 49,42. Now acceleration is negative because it's downwards, so it's going to be minus 9,8 multiplied by time. Okay, now if we move 49 to the other side, it's going to be minus 49,42 minus 9,8 t. Now time can never be negative. If you get a negative time, there's something wrong with your values. Now this becomes 11,77. Okay, now that is a value from the engine when the engine switched off up until it reaches maximum height. Alright, now from the maximum height to the ground, we are going to use this one of delta y is equals to v initial times time plus 1 over 2 a t squared. Now after writing this formula down, we are here. Now the rocket falls from here to the ground, so now when it turns, it waits a little bit, then it starts to accelerate downwards. Now when it's here, the velocity here is 0, so its initial becomes 0, its final is somewhere here unknown. So the equation that we chose doesn't have a final because it is unknown. Okay, now the height is the total height given there. We've calculated it. So since this rocket goes downwards and our upward was positive, the height will be recorded as a negative value of 679,592, which is equals to initial velocity times time. It is 0. Guys, you need to show that it is 0 t, but I'm going to write 0 with due to space. But let me just do it. You guys will just say no, that guy also didn't teach us how to do it like this. Okay, now it's minus 9,8 t squared. This is 9,8 t squared. Now putting everything together, you are going to get your TS remember the other T we got it, I think I made a mistake. If you divide these two, we are going to get not this T, we are going to get the T as 5,04 seconds, and the units need to be there. Now this one is the one that's going to be 11,77 seconds. Okay, now total time taken, because that is what is required, is equals to this plus that 5,04 plus 11,77, which is equals to 16,82 seconds. Now that is the total time after the engine switched off. Okay, now the next question 3.3.2. Okay, question 3.3.2. Alright, now this question it says calculate the speed of the rocket just before it crashes to the ground. Okay, now for you to calculate the speed of the rocket, it's 3.3.2. Okay, now it's going to be VF is equals to, I think the beginning of the video I showed you how I chose these things, the equations. Okay, now I'm just going to write. Alright, now we want the final velocity. Initial velocity, I'm going to take the actual initial velocity that I had, which is 49,42. This is a good trick that I'm showing you, plus the acceleration is 9,8 because we're only considering free fall. Okay, time, I'm going to take the entire time, okay, which is 16,82. Now the final answer, it will give you a negative value, which is minus 1,115,416. It's a velocity, so it's meters per second. Okay, now you can remove the negative and write 115,416 meters per second downwards. Okay, now there will be an alternative method to do this. You are not forced to do it this way. Okay, now alternative method, you can now consider the object when it's already at the maximum height. So when the object is already at the maximum height, V initial is 0, V final is unknown. So you're going to say 0 plus minus 9,8. Then you consider the time that it takes from maximum height to the ground, which it is 11,77. It will give you the value closer to mine. I think that this one will give you 115, but the negative comma 3 something. Okay, it won't give you exactly 42 meters per second, but it will give you something closer to this value, and it is also correct. So there are many ways for you to do this. Okay, and mind you, the question says use only equations of motion, and if you have another method to do it, you can't use it. Now let's draw the graph. So once they tell you that draw a velocity time graph, and then it's under free fall, okay, there's one thing that you need to know about free fall. It is a constant acceleration, which is 9,8 meters per second. And under constant acceleration, that means the gradient of the velocity time graph will be constant, meaning that it is a straight line graph. Okay, it is a graph like this. Now you need to mention this axis, its velocity in meters per second. Now you have time in seconds. That is the first thing you need to do. You also need to draw your graph. So my graph will be like this. Why? Because upwards is positive. Okay, now they said they want to see, so you guys, you must try to follow the instruction here. They said take the time when the rocket engine fails is 0 seconds. Okay, clearly show the following: velocity of the rocket when it crashes to the ground, and time of which the rocket crashes to the ground. Okay, those are the two things they want to see. Okay, so you need this time here and this velocity here. Now that velocity is minus 115,412, and the time here is 16,82. 2. Now every graph here starts at 0. You can put the initial velocity if you're interested, but they did not ask for it. Now this is the end of our projectile question. Okay, I'm going to rub. Now we are going to deal with question 7, which was chemistry. Okay, now and okay, we have question 8. Okay, and question 7. All right. Now 7.1.1, here it says, okay, it says write down the letter that represents the following. Okay, now that is what the question is asking you. Write down the letter that represents the following. Okay, now 7.1.1, an aldehyde. Okay, you guys have this thing, so let me move to where I need to write. 7.1.1. okay, the answer will be a B. B is the one that represents our aldehyde, and reason being it is an O and an H at the end. Okay, double bond O and an H bonded to the last carbon. Alright, now 7.1.2. 7.1.2, the letter, okay, that represents a condensation polymer. Okay, my answer, condensation. Wait, it says a condensation polymer. Okay, I think my answer here was incorrect. I chose D, but I'm not too sure about this one. This question is still under consideration. Okay, now 7.1.3. okay, F. I chose F because they said a compound which has a carbonyl group bonded to 2 other carbons. So a compound that has a carbonyl group and bonded to 2 other carbons, it's a ketone. Okay, so you look at the compound that has a suffix of the word 1, which is the letter F. Okay, now 7.2. 7.2.1, the question says write down the IUPAC name of. Okay, 7.2.1 says compound C. Now when we go to compound C, we can see that it's an haloalkane. Okay, let me go to your question. This is the one I'm talking about, compound C. So it has a BR here and it has a branch there. So now when a branch and a BR or a halogen, they are together, both of them have the similar what do you call, they have similar preference. But now since they're equidistant, if I start numbering from this side, it will be 1 2, and if I start numbering from this side, it will be 1 2. So all of them will have the lowest number possible of 2. You now consider, or you prefer, a halogen over the branch. Okay, So numbering, we're gonna start from this carbon. It will be 1, 2, 3, 4, 5. Now the longest carbon chain is 5, so it has the word pentane. Okay, let me write it here. Pentane. It has the letter pentane. Now we must also notice that it has halogens and an alkyl. Okay, now we have a bromo and the chloro. So when you call this ones, you don't call it like you used to in lower grades like grade 10, where it's a chloride. It's a chloro in a organic chemistry. Okay, and this one is bromo. Okay, now B comes before C. When you write, this one will get preference. So at carbon 2 and carbon 3, I have a halogen. Carbon 2 is a bromo, so I'm going to have 2 dash bromo. Okay, dash 3 dash chloro. Okay, now dash, we go there. At carbon number 4 we have a methyl. Okay, dash 4 dash methyl. So that is the name of this thing. Okay, 2 dash bromo dash 3 dash chloro dash 4 dash methyl pentane. Okay, that is 7.2.1, and you can see it's 3 marks. Okay, it's 1, 2, 3. Now 7.2.2. Let's see what the question says. The monomer of compound D. Okay, the monomer of compound D, the IUPAC name is methane. Okay, now 7.3.1, it says write down the structural formula of compound A. Now I will start to rub because I need space. So 7.3.1. So I need a structural formula for compound A. Okay. Firstly, I need to check compound A. The longest continuous chain is 6-hexane. Okay, so I need to do my longest continuous carbon chain of 6 carbons. So it's 1, 2, can actually put another one, so that's 3, 4, 5, and 6. So no double bonds. Now according to the numbers, I have something at 2, and I also have something at 2. Okay, and I also have something at carbon 4. Okay, now this will be it. And mind you, each carbon must have 4 bonds around it. Don't just leave it like this. I know mistake happens and you can be tempted to leave it like that, but do not leave it hanging. Those H atoms needs to be there, otherwise the marker has a right to deduct marks. Alright, okay, so all carbon atoms must have 4 bonds around them. Okay, and this is the answer for 7.3.1. Now 7.3.2, let me rub. Okay, something on my memo before. Okay, now 7.3.2, it says of compound F. Okay, now pentanone. Okay, so pentanone tells you that it has a body of 5 parent chain, 1, 2, 3, 4, 5. That is the main chain. Okay, then the functional group is at carbon 2. Okay, then the rest are single bonds. Okay, do not tempt to put an H there, it already has 4 bonds. Okay, so guys, that becomes a structural formula for pentanone. Okay, it was penta 2-1. That is a structural formula for that. Alright, now 7.4. Okay, let's see what 7.4 has for us. This was 7.2. Now 7.4. Oh, okay. What am I doing? Okay. It says the table contains compounds which are functional isomers. Define the term functional isomer. Okay. 7.4.1. Functional isomer, we're talking about compounds with the same molecular formula but different functional groups. Okay, now 7.4.2, it says write down the letters that represent compounds that are functional isomers. So it is a B and F. So B, we have an aldehyde, F, we have a ketone. So if we have the same number of carbons, the other one is an aldehyde, the other one is a ketone, then they become functional isomers. If you can check, their molecular formula is the same. Okay, same thing will happen to carboxylic acid and an ester. Alright. Sorry about that. Now let's go to question 8. Okay. Now this is our question 8. Okay, we're given something similar. Now the letters were given letters from P to U. And question 8.1, it is write down the letters that represent the following. A compound may have be used more than once. Okay, now 8.1.1, show us a ketone. So 8.1.1, I'm sorry, I don't know what I did there. Okay, 8.1.1, we want a letter that shows a ketone. It's a letter U. Yes, it's a letter U because it's a ketone, right? Now 8.1.2, show us a carboxylic acid. So let's see, carboxylic acid, it's the letter S. 8.1.3, a compound with a general formula CnH2n. Now that becomes an alkene, therefore will be P, because that double bond of carbons. Okay, now 8.1.4, 8.1.4 says two compounds that are functional isomers. Okay, it will be Q and S. If you look at Q is an ester. S, it's a carboxylic acid, and previously I mentioned that these two are functional isomers. Okay, now 8.2.1, they want an IUPAC name of T. So IUPAC name of T, it's going to be 2,3 dash dibromo dash 4,4 dimethyl. Now the parent chain has 5 carbons, so it becomes pentane. Okay, now 8.2.2, we want U. So how do we name U? Do we want U? Yes. Now U, we said it's a ketone. Okay, so it's going to be hexane dash 2, not dash 2, I'm sorry, but dash 4. Dash 1. Okay, that is 8.2.2. Now 8.3.1, 8.3.1, it will want a structural formula. Okay, 8.3.1, we want the structural formula of Q. So Q is an ester. So the first part is from an alcohol which behaves like an alkyl. Okay, then the second part is from a carboxylic acid, then it becomes a main branch when it arrives at the ester. Okay, so that's what you need to know. Now this is our structural formula. Okay, now 8.3.2, another structural formula, okay, of R. Okay, so main parent chain is 1 2 3 4. 1 2 3 4. Then carbon 2 OH. Okay, H H H H H H. There's supposed to be an H there. Guys, remember that your carbon must have 4 bonds around it, okay? It's possible for you to forget it, but please try. Alright, those are the two structural formulas that we need. Alright, now the last question, which is 8.4. It's a theory question. They say compound R is a secondary alcohol. Explain the term secondary alcohol. Okay, we have 3 types of alcohol. We have a primary alcohol. The carbon with the functional group is bonded to only one other carbon, okay, but in this case we are asked for a secondary. We say a carbon with the functional group group is bonded to two other carbons. Okay, now tertiary alcohol, you will say carbon with the functional group is bonded to 3 other carbons. That is the difference. Okay, so this is the end of the session, guys. Please remember to like the video, subscribe, and share it with your friends. Okay, cheers, guys. Have a nice evening.